Okay, gonna look at a problem that figures out how fast a baseball was thrown, or actually the velocity. So it's gonna have to include speed and direction. What we know is two things. It landed 50 yards away from where it was thrown, and it was in the air for 3 seconds. 50 yards isn't going to work for us, so we're going to have to convert that. So I took 50 feet times 3, 50 yards times 3, giving me 150 feet. Then I just use a conversion of 3.28 feet per meter, and I get 45.7 meters. We'll do 2 sig figs at the end of this problem. Okay, so here's what I know. It landed 45.7 meters away, took 3 seconds to get there. So this becomes a vector problem. We have a sideways velocity of 45.7 meters in 3 seconds gives us 15.2 meters per second. And an upward velocity based on the 3 seconds in the air. Now 3 seconds in the air means 1.5 seconds of falling time. So the falling time is 1.5 seconds. In 1.5 seconds, we know gravity will speed something up 9.8 meters per second every second that it falls, times the 1.5 seconds of falling, means that ball came down with a velocity of 14.7 meters per second. If it came down at 14.7 meters per second, then it went up at 14.7 meters per second. So what we want to do now is combine these two vectors to figure out what the ball was really thrown at. And you should make your little parallelogram method here so that we know everything's in the right spot. We're going to find the velocity, so we're going to need not only the length of that vector, but the angle as well from the ground. So I'm going to use Pythagorean theorem, and I have 14.7 for a squared, and b I'll use 15.2 squared. Square root that, I get 21 meters per second. So we know the speed, now we just need the angle. If I look at my triangle over here, I've got the opposite side being 14.7, and I've got the adjacent side being 15.2. So inverse tangent of opposite over adjacent will give me the angle. And I get 44 degrees. So final answer for this problem is the ball was thrown at 21 meters per second at 41 degrees from the ground. So I'd write that out there. And there it is. That's my final answer. The vector answer is the velocity to the softball throw.